Hello everyone. In this video, we are going to determine the wavelength of prominent lines of mercury spectrum using a transmission grating. For this experiment, we need a diffraction grating, spectrometer, mercury lamp and a reading lens. The wavelength of the light should be of the order of slits of grating, then only diffraction occurs. To find the wavelength of the prominent lines of mercury spectrum, first we need to determine number of lines per meter of grating for a diffraction pattern of nth order. So the formula will be n is equal to sin theta by n lambda. From this formula, we can find the wavelength by lambda is equal to sin theta by n. We will find capital N, that is number of lines per meter of the grating, by assuming the wavelength of green line as 5461 Armstrong. And we are taking the first order of the spectrum, so small n will be 1. To start the experiment, level the prism table with the help of spirit level. Bring the telescope in line with the collimator to have a sharp image of the slit. After adjustments, rotate the telescope through 90 degrees in clockwise direction and fix it. Now fix the grating on the prism table. Turn it slowly through 45 degrees such that it gets the reflected light from the collimator. Now release the vernier table and rotate by an angle of 45 degrees normal to the grating. Bring the telescope to be in line to receive the image of the slit on crosswire. Note the position of the telescope. This corresponds to the direct ray. This method is known as normal incidence method. Now rotate the telescope to the left side or right side of direct image and you can see the spectrum is obtained. Now rotate the telescope to any one of the side and observe different spectral lines turn by turn on vertical crosswire for first order. Find out the vernier readings for each spectral line. The angle is twice the angle of diffraction for that particular color. Half of it will be the angle of diffraction. Now take mean value of theta for different colors. By this experiment, we found the wavelength of the prominent lines from the mercury lamp and the results are tabulated.